Welcome to Math 1324, Section 8.2. We continue looking at probability. What we see here on the right is called a Venn diagram, and it's a way to represent sets. So first off, notice the box. The box is S, which is our sample space. And our sample space has A in it, and it has B in it. And this number represents the count of how many things are outside of these two circles. The part where A and B overlap, the intersection, there are 35 things in there. Just in A is 13, just exclusively in B is 22. So first off, how many things are actually in all of S? Well, count it up. 13, 35, 22, 30, and we get 100. So the number in my sample space is 100. And so to get this number, the probability of A union B, I just need to know how many things are in the union and divide that by the number of things in the sample space. Well, let's see. Looking at this diagram here, where do we get the 0.13? Well, A has 13 in it, so 13 out of 100. This was 35, and so that came from 35 over 100. And the 0.22, 22 over 100, and the 30 on the outside divided by 100 is 0.3. So how many are actually in the union? Well, it's 13, 35, 22. Add them all up, I get 70 over 100, which as a decimal, see they say they want a decimal answer, is 0.70. Alright, in question 2, we continue with the Venn diagram. So let's see, first off, how many things are in S? Well, there's 15, 21, 38, and 26. And we add in the 38 that's in the middle, 38 in the middle, and we get 100. So this is 100. So now what is this stuff? A intersect B. Well, that's the stuff in the middle. There's A intersect B. Now the little complement means everything outside of the intersection. So if I add up the stuff outside of the intersection, well, how many things are there? Well, there's 15, 21, and 26, and that adds to give me 62. The little complement means outside of the intersection. Other than that, they just filled in the diagram with decimals from the 15, the 38, the 21, and the 26. So again, this little tiny little slash up at the top means everything outside of. So simply count the things outside of it. Alright, so let's see. In question 3, we have our single playing card. So F is the event of getting a black face card. Now what does that mean? We know that there are 26 black cards. What does that mean, a black face card? Well, the only cards on them that have faces, actual faces, are the jack, the queen, and the king. So we've got clubs that are black, and they have 3 of these face cards, jack, queen, and king. And spades are also black, and they have 3 face cards. So there are a total of 6 black face cards. So if that's the was what we needed, that would be the end of the story. But notice they have find the probability of F, which is the black face card, complement. So everything outside of it. Well, it's fairly easy to do to find this because all we have to do is take 1 minus the probability of F occurring. We knew that was 6 out of 52, and so 1 minus 6 over 52 is the same as 1 minus 3 over 26, which is 23 out of 26. So really the easiest is to figure out what you need, then take the complement, which is simply 1 minus that. All right, in question 4. Again, a 52 card deck. E is a spade. We know there are 13 black spades. What do they want? Find the probability of E complement. So not a spade. Well, if the number of spades is 13, then the number of not spades is 52 minus 13, which is 39. So the probability of not a spade is 39 out of 52. I can take a 13 out of both the top and the bottom, and it reduces to 3/4. Question 5 gets a little more complicated here. All right, let's see. D is the event the card is a heart. Okay, well, we know there are 13 hearts. And F is the event that the card is a 2. Well, there are 4 2s. All right, now they want us to find D intersect F complement. So let's see, if there are 4 2s, then not 4 2s is 52 minus 4, which is 48. So there's 48 cards in it. Some of these cards are red, some of them are black. What do we want to do? We want to take all of the D, which is hearts, and I want to intersect that with the complement of the 2 cards. Okay, so let's see. What's in there? Well, let's see. First off, it's going to have D, which is going to have all the hearts, but the 2 of hearts is missing, okay, since it wasn't in there. And so it's going to have the number in there is 12, and so the probability is 12 out of 52, which reduces to, taking a 4 top and bottom, 3 over 13. In question 6, we have 26 balls in a vase or something, in a bowl, and they're numbered 1 through 25. Okay, so I got numbers on these balls. All right, so far so good. We want to find the probability that it's either odd or a multiple of 6. Well, what are these outcomes? The odd numbers are going to be 1, 3, 5, 7, 9, 11, all the way to 25. or a multiple of 6. So let's see. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and 6 times 4 is 24. All right. Do we have any overlap between these two? Is there any chance of me double counting? Well, no. Since all the multiples of 6 are even numbers, so the question is, how many odd numbers are there? If you count up all the odd numbers from 1 to 25, and there are 13 of them, you've got 4 multiples of 6, and so it is 17 out of 25, which as a decimal is 0.68. I have to put it in a decimal because, again, my math lab wants it as an integer, which it's not. So therefore you have to put it in as a decimal. And finally, if the probability that someone wins is 49%, what's the probability that they're going to lose? Well, it has to add up to 100%. So 100% minus 49% is 51%, and so 0.51.